Hi guys, this is Dr. Gonzalez, and I'm here with you today to talk about replication of research studies. You're going to learn that replicating research studies is an important thing in the research world. We're going to talk about the different ways that we often approach replicating research studies, as well as some of the issues that people run into when it comes to the quality of their research in general. You'll notice there's a little cartoon here. It's showing some researchers that are trying to replicate the Milgram experiments. You'll recall from the chapter on ethics that Milgram's studies were where they were giving shocks supposedly to friends or cohorts in the experiment, and they were testing authority. And the joke with this is that they're having trouble finding people who've never heard of the study. So, could be a problem. Anyway, so why is replication important? Well, first of all, replication is the process where we repeat a study to see if we get the same results again, right? It's not enough to do a study one time. A single study can never prove everything that we need to know about an issue. So replication is going to help us as a researcher increase our confidence in our own results, increase our credibility as scientists and researchers, and lend more reliability to the conclusions that we have come up with. Now, there's a replication crisis out there that shows that a lot of the things that end up getting published have results that are either difficult, if not impossible, to reproduce. And that has led to a movement or a push to improve our research practices. And we're going to talk about some ways that we could do that in this video. So why do we need these replication studies? Well, first of all, replication studies help us confirm that what we found in our research is real. Okay? So if I can repeat those results, it helps me determine if my original findings were accurate or if I just found those results due to chance. Because remember, there's always in the research world and in our statistics that we run, we're trying to find out if there is a significant difference between or with our variable that we're testing, right? And there is always a possibility that if we find a significance result, it's actually due to chance. All right. And the second reason I had stated earlier was that replication studies help increase our scientific credibility. So when you produce studies that back up the same results that you found, the public and other researchers are going to trust you more. And those conclusions can be taken and really trusted as good science and good conclusions. And then the third reason that we absolutely need replication studies is that those studies help us identify errors or bias in that original research. Remember, we all make mistakes. Research can make mistakes as well. So by replicating these studies, we can find things like if our methods were flawed or if there was some bias in the original study that led me to the results that I found. Okay? It also helps us test our reliability across different samples. Okay? Obviously, when you're replicating a study, you're going to use a different sample each time. So every time you do that, you're helping to determine if the results that were found in the original study actually do apply to a wider population. Take, for instance, what if it was something unique to that sample that you picked? The only way I could really determine if that was unique to that population is to test it in a sample. Unique in that original sample is to test it in a sample that is different from the original one, and that helps us get closer to that population. The more people we sample, the closer we get to that population. Replicating studies also helps us reduce the impact of false or exaggerated findings. Some studies show a strong effect that later on turns out to be weak or maybe even not existent at all. Replication helps us as researchers go back and correct those problems. And then finally, replicating studies helps us strengthen the larger body of knowledge and the theories that we extract from that. So as long as we get consistent results across studies, we're providing stronger evidence and support for any scientific theory that might come out of that original research. Let's go over several of the different types of replication. The first one is direct replication, and this is when you as a researcher repeat a study following the methodology and all the parameters as closely as possible. So in other words, you really do want to create a carbon copy or a clone of that original research, because your goal is to verify the original results. Obviously, if your results are similar, you've got stronger evidence for that original research conclusion. Here's a short little example. So a researcher conducts a study to test whether retrieval practice or quizzing improves memory compared to simply rereading your notes. Okay? In the original study, we have some students who took a practice quiz and they performed better on a final test than students who just reviewed their notes. So if I were going to directly replicate that, a new researcher is going to come along and they're going to use the same procedures. They're going to use the same kind of quiz, the same timing, the same materials, and they're going to follow the steps that were followed in the original research study as closely as possible. Make a note of this, because when I told you guys in your video explaining your final research project proposal paper, in the methodology section, under procedures, I told you to tell me in detail exactly what the procedures were that you intended to follow. This is one of the reasons why. If I wanted to come back along and replicate your study, I need to know exactly what you did. Okay? So now we're following the same steps as closely as possible, and we're going to test a similar group of students. Obviously, we don't test the same group, right? But I want to use the same group, same parameters, same age, same grade level, whatever I'm looking at. And if my new study finds the same or similar result, and the result we're looking for here is that quizzing improves memory, I have support for that original finding. The second kind of replication that we're going to discuss is something called conceptual replication. And in conceptual replication, we're testing the same idea, but we're going to use different methods or measures to get at the meat of the problem. So the goal here is to show that our findings aren't dependent on that one specific procedure. So here's an example using the same parameters as the first one that we discussed here. A researcher studies whether retrieval practice or quizzing improves memory. In the original study, students either reread their notes or they took a short quiz. The result was that the students who took the quizzes did better on their final test. If I were going to conceptually replicate this study, a new researcher would come along and test the same idea, but they might change the method. So instead of using multiple choice quizzes, they might use short answer or vice versa, whatever opposite of what was used in the original study. Or this time they might use the same procedure there, but use a different material. Maybe this time they're looking at a vocabulary passage instead of a reading comprehension passage. But the goal of this is to see if the same pattern of results still occurs, even though you've got some differences in your study this time. The third kind of replication we're going to talk about is replication plus extension. And in this kind of replication, we're going to repeat the original study, but we're going to add a new variable or a new condition, because the goal of our replication here is to expand knowledge and test a new question. Going back to the original scenario, again, I have a researcher studying retrieval practice, quizzing improves memory. In the original one, I had some students who took a practice quiz. They scored higher than those who only reread their notes on a final test. In a replication plus extension, I'm going to come along and I'm going to repeat the original study, same quiz versus rereading conditions, but I'm going to add a new condition to it. So the new condition I might add is that I add a third group that uses flashcards or spaced practice. And I might also want to look at blocked versus interleaved quizzes. Then I can go back and compare my original condition to the new condition. Now you will note these 3 examples were not non-experimental. These 3 examples were actually experiments. That doesn't mean that you can't replicate or modify with extension a non-experimental study. These were just the examples that I came up with off the top of my head, and after I wrote this I said, well dang, I should have really done, a non-experimental example, but it is what it is. You guys can understand this. Let's talk about large replication projects. So a lot of our research that we conduct is kind of isolated. So take, for example, some of the research that you may participate in at UHCL through SONA. It might be a very small study run by a professor or maybe a graduate student. And it on the grand scheme of research, it's pretty small. Well, a large replication project involves several different research teams, and they're working together to repeat the same study across different locations. So maybe after your professor in SONA does their pilot study there, they get together with other psychologists at other universities, and they work to implement the same research, same procedures, same research question, etc., but they're now testing in 10 different locations. So you have reached a point where you're now getting closer to a more representative sample of your of the population that you're studying. You're sampling more people. You're looking to see if those same standardized procedures give you results that are going to be consistent across different populations, different settings, and different researchers. So the goal from this type of replication is that we want to produce reliable and generalizable findings that are more than just a single study. So we're going big in this particular situation. Large replication projects let us achieve several different goals. First, they let us test consistency of results, because if I find the same results across different labs, my results were more likely to be valid in the first place. Second, they may help reveal patterns of variability. So we might discover that our results are going to be different depending on our location, our sample, our context. So that adds another layer of depth to the original study. We might also see more accurate effect sizes, because the larger your sample gets, it often shows that effects are smaller than they were originally reported. And then it also helps increase transparency and collaboration. Anytime you have more researchers that are working on the same thing, you're sharing data, you're sharing methods, and you're discussing what's going on more openly. There's less likely a chance for you to hide something. And collaboration is a great goal, especially in science. Sometimes you'll run across the word meta-analysis. This is probably something you may have run across if you were doing your literature review for your paper. You might have come across a meta-analysis, but a meta-analysis is a statistical method that combines the results from multiple different studies. And what it does is it produces an average effect size across all the research that's been done on that particular topic. And what it does also is it helps us determine the overall strength of the body of evidence that we have at the moment. So some of the strengths of a meta-analysis is, first, it uses large data sets, and so that helps lend itself to more reliable conclusions. And second, it's very useful for identifying patterns across different studies. But just like anything in science, a meta-analysis still has limitations. So first, it can be biased if the only published studies out there about the phenomena that you're studying were included in your analysis. That's publication bias, okay? And that's not necessarily something that you, the researcher, can control in a meta-analysis, because we already recognize that there's a bias in publication. We talked about this way back at the beginning when we were talking about sources of information. There is a bias in publication in which journals want to publish things that were significant, and they don't really tend to publish things that aren't, okay? And the quality of your meta-analysis is limited to the quality of the studies that you included. So in other words, garbage in, garbage out. If you include garbage in your meta-analysis because the garbage was published to begin with, then your meta-analysis is also going to be garbage. In a meta-analysis, a researcher collects lots of different studies on the same research question. They extract the effect size from each study, and they combine those effect sizes together to get a single overall result. Studies that have larger sample sizes are usually going to be given more weight because we consider studies with larger samples to be more reliable. Now, you might be going, I don't remember what effect size is. Well, effect size measures how strong the relationship or a difference is between variables, right? It goes a bit beyond, is it significant or not, okay? So we've been dealing with all or none with our hypothesis testing in correlations, regression, non-parametric tests, all of the tests that we've been studying in this class. We've been dealing with black and white. It's either significant or it's not. Well, once you've determined that it's significant, an effect size is going to help determine how big that effect really is. All right. So, for example, if you've got a small effect size, that means there was a difference, but it was small between the groups, right? The large effect size means that whatever difference you found was big, significant, and very meaningful. Now, meta-analysis has several different strengths. Number one, it lends itself to more reliable conclusions because it combines all that data from different studies instead of just relying on the data from one study. It also helps us get a large overall sample size, which increases our statistical power and the accuracy of our conclusions. Meta-analyses also help us to identify patterns, and they help to determine when and where those effects actually do occur. And then the last one here, it says it resolves conflicting findings. So a meta-analysis might help to explain why two studies that are very similar or almost exactly the same produce different results in the real world. Now, there are limitations of a meta-analysis as well. Number one, I talked about this already, publication bias. So we already know there's a bias out there to publish studies that have significant results. So as a researcher doing a meta-analysis, since I'm limited to probably only the significant results, I'm missing a whole nother set of research situations that I don't have any access to those studies. As I told you a couple of minutes ago, garbage in, garbage out. If the studies that you are including in your meta-analysis are poorly done, then your research is going to be misleading and probably not very valid as well. And then there are differences between different studies. So the simple fact that a researcher uses different methods from his or her colleagues, different ways of sampling, different populations that they're sampling from, or even different measures can make it difficult to compare the results between different research publications or different research studies. Now, why are meta-analyses important? They're very important in helping provide a big picture of all of the research findings that exist. It helps scientists make evidence-based conclusions. So evidence-based is a word that you will hear in a lot of different contexts. If you're an educator, you're going to hear evidence-based interventions. If you're going into therapy or social work, you're going to hear evidence-based therapy. You might even hear that in medicine. But this type of research and the conclusions that come from it play a major role in psychology, medicine, and education. Okay, let's go over some of the questionable things out there in research. And these apply to both research and the replication of previously done research. We're going to discuss p-hacking, which is when you try multiple analyses until you find something that sticks. HARKing, which is creating a hypothesis after you see the results. And then simply underreporting our null results, which is ignoring when we didn't find anything. All three of these particular practices reduce our trust as researchers, and they also reduce the ability to replicate our findings should someone choose to do so. So p-hacking. P-hacking is when researchers manipulate a data analysis in order to get a statistically significant result. And remember, we used the level of p is less than 0.05 in all of our analyses. So instead of testing a planned analysis, they may try several different approaches until something works. So they may go in and adjust that p-value. So they may go in and say, well, instead of p is less than 0.05, I'm going to go with a p is less than 0.1. So now they've increased the possibility of finding a significant result, and they've basically manipulated what they've done. How would you do this if you were a researcher? Well, they might test multiple variables and then only report the results of the ones that were significant. They might try different statistical tests until one gives a desired result. They might take the data and throw out the outliers. Like, for example, I could go into the test 2 that we just took. I had a very negatively skewed data set. I had 96% of the class with excellent scores, I would say an 80 or above. And then I had a handful of less than that. And there was one in particular that was very low. And so I might throw out that one super, super low score in order to make my results look better. Okay? Researchers might also stop collecting data when they reach a level that is significant, or they may even split the data into subgroups until they get a significant effect. So maybe they collect a whole bunch of data on university students, freshmen, sophomores, juniors, and seniors. And then they might go, well, I'm going to go by gender and analyze it here, and they find out, well, okay, it didn't look, let's keep going. I'm going to look at freshman females. I found something that's significant. Now, I'm not saying that that isn't something that's important. There may be contextual situations where that is important, but it's almost like fishing for a result when you haven't said from the beginning, this is what I'm going to do. So all of these choices that are listed in p-hacking are made after you look at the data. They are not planned in advance. Why is p-hacking a problem? Well, it increases the possibility of a false positive. So you're just fishing. If you find something that's significant, it may be just due to chance. It also reduces your ability to replicate the study. So you fished around and found something, and then another researcher comes along and tries to replicate your findings, and they're not able to do that because, hey, you fished till you found something. And overall, p-hacking misleads science and the public because it creates an illusion of a evidence of something that's super strong when there really isn't any evidence of that conclusion at all. So here's an example, a very simple example of p-hacking. So you have a researcher that wants to test whether listening to music improves a test score. And what they do is, from the outset, they try different genres of music. They might try jazz, classical, rap, country, norteño, I don't know. Then they might look at different lengths of the music. Oh, I'm going to play it for 15 seconds, for 30 seconds, for 20 minutes. And then they go to different groups. Well, I'm going to try it with high schoolers, freshmen, sophomore, junior, seniors in high school. Then I'm going to look at freshmen in college. And you know what? I'm going to end up with graduate students. And after they've done so many tests, they find maybe one or two things that are significant, and they only report those things. Now, because they're limited so much in the significant results that they found, those results that they found may be just due to random chance. They're not really real. All right, let's go to HARKing. HARKing is an acronym that stands for hypothesizing after the results are known. So you've all been working on writing a research paper, and since maybe the third week of class, we've identified our null and our alternative hypotheses, right? There is a significant difference. There is not a significant difference. Well, HARKing is when you don't do that at the beginning. You do your research, and then after you've analyzed the data, you come up with, or if you came up with first, you change your hypothesis. And then you present that as if you were planning to test that hypothesis all along. So here's an example. A researcher runs a study without a clear prediction, or their original hypothesis isn't supported. So they analyze the data, they notice a cool pattern, they then go back and rewrite their hypothesis to match the results, and then they report that their study was done with a preconceived hypothesis that came before their data collection, when in actuality it was written post hoc. Why is HARKing a problem? Number one, it misrepresents the scientific process. In the process of research, our hypotheses come before our data analysis, okay? It makes exploratory findings look like a confirmed prediction. We base our predictions based on the previous research, okay? Exploratory processes are not, they're needed in some areas of research. But in psychology, more than anything, because that's what this class is. It's a psychology class, right? We operate in a strict series of parameters that indicate that we come up with our hypotheses based on previous research findings or something that we know about the groups that we're working with and or the variables we're dealing with. So we've got to make sure that we are true and fidelity is there to the scientific process. Second reason why HARKing is not good is it inflates false confidence. So it makes our results seem stronger and more reliable than they really are. And then the final one is that it hurts the ability to replicate our study's findings. So if I base my findings on a post hoc reasoning, obviously, when I publish this stuff, I'm probably not telling the world that that's what I did. So when Joe Researcher from SMU comes along, tries to repeat my research, they don't know that I manipulated this stuff, and they're more likely to not find the same thing that I found. Here's a HARKing example. So a researcher studies whether sleeping improves test performance. Could be a math test, I don't know, any kind of test. The results showed that sleep didn't have any effect, or there was no association between sleep and test performance. But they were also collecting some data on stress. And when they got the stress levels, they found that there was a correlation between stress and the test performance scores. So instead of reporting it honestly, they come out and say, well, we predicted that stress would affect performance. In actuality, they were studying sleep. So what they did was HARKing. They changed the story after they saw the results. The third thing we're going to discuss here with these issues of our reliability and our trustworthiness as researchers is the concept of underreporting null results. So remember, a null result tells me there was no effect, or there was no correlation, or no relationship, or no predictive value between variable X and variable Y, right? So that null says there was no difference or no meaningful relationship between those variables. Underreporting that null happens for several different reasons. First is that journals simply prefer exciting results. And if you didn't find a significant result, that's not necessarily very exciting to that journal, okay? Ourselves as researchers often feel pressure to only publish positive findings, and we want to avoid results that seem like failures. So null findings are often seen as less interesting or less valuable. But in the reality and the actuality of research, null findings are not. But we're fighting an uphill battle here. If we can't change journals and our collaborative peers, if we can't change their minds about the importance of null findings, it's kind of a moot point, okay? So why is it so bad that you underreport null results? Well, first of all, it presents the scientific record about a certain topic or research area as being biased. So when you run a literature review, you're going to see positive results. Okay? That's all you see, and you have no idea how many studies that were actually conducted that actually found no effect. Underreporting the null also overestimates our effect sizes. So what that means is it makes a relationship appear stronger than it actually is. Now, as a researcher, if you are basing your future research projects, writing grants, advising graduate students on what areas they should go into for research for their thesis or their dissertation, and you're basing it on all these positive things that you've seen out there in the literature without having any idea of the null results, that's misleading to future research and decision making as an ethical scientist, right? So if we're educators, scientists, or policymakers, and we're relying on that incomplete or inaccurate evidence or picture of what's going on, we're missing something huge when it comes to those variables that we're working with. Finally, underreporting the null contributes to a replication crisis, okay? When you've got a whole bunch of unpublished null results and they're consistently ignored, it helps further the idea that findings are going to be less likely to hold up over time. Okay, we don't have an accurate picture of what's going on, and that's really important in our overall professionalism as researchers. So here's an example of underreporting null results. Sorry, this was supposed to say 10 right here, so I will go in and just add a little 1 in front of that, and I'll go back and fix it in the notes. But 10 studies were testing whether a new teaching method improves test scores on a kindergarten level reading test. 7 studies showed no effect. We retained the null hypothesis, okay? There was no association between the test scores improving and the new teaching method. 3 studies did find a small positive effect. We're only going to publish those 3 positive studies. And what that does is it makes that intervention, that new teaching method, look like it works much better than it actually does. Because, hey, I've got 7 studies here that said this stuff doesn't work. You see where the problem is with that, right? All right, I've lost my cursor. Sorry about that, guys. All right, so what are we going to do as researchers to help change the world out there with regard to reliability and trustworthiness as researchers, especially when it is involving replication? First, we want to adapt a philosophy of transparent research practices. So how can we achieve that? First, we want to use the idea of open data. That means when I collect my data, I'm going to put it in a data set and I'm going to share it publicly. Now, that requires some modifications in our IRB procedures, right? We've got to include a statement to our participants that this data could be used for other analyses done by other people. I would go so far as to say that IRB would have to approve that these data sets would be anonymized and they're no longer confidential, right? It's confidential in that I'm hiding who you are as the participant, right? I'm coding that. But your data is now publicly available out there. So we want to make sure that it is removed of all identifiers before that happens. And that is a procedure that has to go through IRB, right? And there are always going to be some people who, despite what you tell them about you protecting their data, with good reason, they're not going to trust you. I mean, we've just had too many experiences in the world out there where somebody's hacked somebody else and gotten data, okay? Another way that we can foster transparent research is to openly share our materials. So mainly that's referring to the methods and the procedures that we used, okay? And then there's this concept of pre-registration. So pre means to do something beforehand. Register means to make, a record of something. So by pre-registering, we are going to come out and state our hypotheses and our methods before we begin collecting data. And I need to go back and research a little bit more about this, because if your research project is going through the IRB, to me, I remember when I did my IRB, I had to tell them my procedures and methods, but I don't necessarily remember telling them my hypotheses. And I don't know that it would have made a difference either way. So by pre-registering, is there like some big, entity out there where you submit your pre-registered hypotheses and methods before you start collecting data? I don't know. I will have to ask somebody, because I haven't been in the research world recently, and I'm not exactly sure about that. But these particular actions here help us as researchers maintain our honesty. They hold us accountable, and they help our research to be able to be replicated and reproduced by other researchers after we're done. All right. Remember back to our discussion on validities. We talked about 4 different kinds of validity, and one of the kinds we talked about was something called external validity. And external validity is how well our results can be generalized. And by generalized, we mean how well can I apply these results to real-world situations. The key issue here with our studies is how representative was my sample of the population. Okay? You've got to remember that in research, it's not just about your sample. It's about the population that you sampled from. That sample hopefully is representative. And by only testing 50, 60, 70 people, your results would be no different than from testing 500, 5,000, 5 million, okay? Remember, random sampling is always better than convenience sampling, and that provides a little bit of a challenge when you're doing non-experimental research, because random sampling could be used, but it is a characteristic of experimental studies. We often find ourselves in non-experimental research limited to the populations that we have to study because of the nature of the observational characteristics of our study. So we're going to use convenience samples because they're there and they represent what we need. So just remember that in general, in science, an experiment is better than a non-experiment. And random sampling is more likely to lend itself to more external validity than a convenient sample. And then you've got this thing at the bottom. It says bigger samples are not equal better if they are biased. So what that means is a bigger sample is always better. But it doesn't matter how big that sample is if that sample is biased. Okay? I can have all the people in the world in my sample. It can be super wonderful with the number and the power it's going to give me and the effect size and all that good stuff. But if that sample was chosen in a way that was biased, then it's not exactly the situation that lends itself to high external validity, just depending on the context and the situation. Now, the big question that comes up a lot of time is that who are you doing your study on? And for example, SONA. SONA is a wonderful interactive way for your professors and graduate students at UHCL to conduct ongoing research using a population that has an incentive to participate in that research. Because you'll recall that as a student in this class and as a student in the experimental class that you'll also take if you're graduating as a psychology major, you're required to do at least 3 hours of research studies in SONA each time you take that course. That's a convenient sample. And you're already limited with several different variables by using that college student convenient sample there. There's a whole group of people that I'm missing, which primarily would include people who are not college students. Okay? Another issue is that we run into what's called weird populations. Weird population stands for Western, educated, and industrialized. Because again, that is where research is taking place in typically what we consider the Western world. Typically, you're pulling from educated populations, and typically those countries that are engaging in this research are industrialized. And what that does is it provides me a great picture of Western, educated, industrialized populations. It also leaves a huge gap out there in our results. That gap limits how well I can apply those findings globally. And if you think about some of the major things that we're interested in research, like anxiety and depression, or schizophrenia, or ADHD, autism, all of those things, there are inherent differences in the diagnosis and treatment of some of those disorders based on whether or not you're in a Western versus a non-Western country. So it's important to recognize the cultural lens that we're using to look at our research, right? Cultural lens talks about the seeing of our research through our eyes. American university attending students, right? That limits how well we can apply any results that we find to the greater average world out there. We just have to be very careful with that. You've got to take those cultural considerations. Again, psychological processes may not work the same across cultures. An example, I remember reading a study about a group of people in a country in Africa. I'm sorry, I can't remember what country it was. But the typical hallucinations that we associate with schizophrenia, auditory and visual hallucinations, commanding hallucinations, etc., things like that. In their culture, they tended to see hallucinations as a companion to the person throughout life, and they embraced those hallucinations as a component of the person themselves. And what we found when we did this research was that they were less likely to hear the commanding, I believe, command hallucination to go do something, or they embraced those hallucinations in a way that did not necessarily portray judgment the way that we often judge in the Western world. If you're hearing or seeing things and you disclose that to someone, the simple fact that you disclosed hallucinations makes people just make a check mark on your record there, and you're kind of labeled, right? So there's a cultural context to a lot of different things. We have to remember that psychological issues and processes are different amongst cultures, across different cultures. There's an example in your book. It talks about visual illusions, like Mueller-Lyer. That varies across societies, so you got to go back and look at that in your book. And you, as a researcher, just need to avoid that assuming that your results that you find are universal. There's a nuance to research in different cultures, and until you can carry out that same research in a specific culture, the results you found may or may not be valid for that culture you're dealing with. So the key takeaways from this presentation: we need replication because it's essential for doing good science, right? We also need to know that sometimes the reliability of the findings that we found is a lot less than we thought. We help combat those problems by transparent research procedures because that improves our research quality. We also need to remember that generalization depends on who we studied and how we did it, and we as a general body of psychologists need to move beyond weird, Western, educated, industrialized samples to other groups and study more of the underrepresented, underserved populations, so that we get a better overall picture of how things are out there in the real world. So I don't have any information just yet on your assignment for this week. This is probably the last video of content, lecture content, that you're going to have in this class, because this is getting towards the end. So I will more than likely produce another video for you to talk about the expectations and the upcoming assignments that we have. So for now, that's all. I hope you enjoyed this video, and take care. Bye-bye.